Hello friends, in this video we'll be discussing type number 3 of inverse Laplace transform, that is use of differentiation of phi s property, problem number 3. Welcome back friends, let us discuss problem number 3 of use of differentiation property. So this is problem number 3. Here there are two factors, 1 upon s multiplied with this. So please tell me how to solve this problem, how to start the problem. First of all, this 1 upon s is with multiplication of this particular term, right? First of all, forget about this. Just follow me and I'll explain you everything. First of all, forget about this. If you forget about this, you will be left with this particular term. So let us find it out, Laplace inverse of that term. Okay, so that will be Laplace inverse of, let us consider, first of all, find it out Laplace inverse of this term without considering this particular 1 upon s. So how to find Laplace inverse of this? This is log property. So first of all, let us take LCM here. That will be s square. If you cross multiply, that will become s square plus 1. We know the property of log A minus log B, which is equal to, obviously if you separate you cannot find it out the Laplace inverse. Therefore in case of log, we're gonna use this property by use of differentiation of phi s. Because of this property, it will be minus 1 upon t is there from the formula into Laplace inverse of log of s square plus 1 is what? 1 upon s square plus 1 into s square derivative is 2s. What about this? Here also log of s square derivative is 1 upon s square into s square derivative is 2s. In short, this is minus 1 upon t Laplace inverse of 2s upon s square plus 1, and here if you cancel this s, it will be 2 by s. Now if we separate Laplace inverse here, that is 2 is a constant, s upon s square plus 1, its Laplace is cos t, minus again this 2 is a constant term, 1 upon s Laplace is 1. Here you can take 2 common, inside you will be left with cos t minus 1. So this is your Laplace inverse for this particular term. But with this particular term we do have 1 upon s. So what to do with this 1 upon s, that you need to remember. What to do with this 1 upon s? So you can directly take it as a formula. See the formula, Laplace inverse of 1 upon s into phi of s is equal to integration from 0 to t into fu du. You can directly take it as a formula. I'll explain you, don't worry, how the formula came, and few students might have already got it, how the formula came from. See here, it's very simple. Suppose this Laplace inverse goes to that side, that will become Laplace. This will become Laplace. And remember this Laplace of 0 to t, this is which property? Laplace transform of integrals. So what we do in Laplace transform integrals, we forget about the property. So let's forget about it. You are left with what? F of u. And I've told you several number of times, whatever will be inside this integration 0 to t, we gonna write it down in terms of u. So 0 to t, we're gonna write down in terms of u. Forget about this property. You are left with f of u. Its Laplace is phi of s, and due to this 0 to t, I'm going to write 1 upon s. That's it. Is this clear? Due to this 0 to t, I'm going to write 1 upon s. So this is the formula that you need to remember. So whenever we get 1 upon s with any function, what you need to do, forget about this 1 upon s, and because of this 1 upon s, we're gonna integrate from 0 to t to whom? Laplace inverse of this particular term. So we'll be using this as a general formula. So in our case, Laplace inverse of 1 upon s into log of 1 plus 1 upon s square is equal to, see this, because of this 1 upon s, it will be inside this integration 0 to t, Laplace inverse of this term. So Laplace inverse of this particular term. Leaving 1 upon s, whatever is left is phi of s. This is my phi of s and its inverse is this particular term. And whatever we write it down inside this integration, we write in terms of u. So it will be minus 2 by u cos u minus 1 into du. That is your required solution. That is it. No need to solve further. No need to solve further. Actually, you can't solve. Basically, this is the main thing. Because here it is divided by u. And since because of this u, this integration is further not solvable. Therefore, if in the exam you finding this particular question or this type of problem, you gonna keep it as it is. That's it. That's your required solution. Suppose if there is no u, suppose if there is no u, then in that case you need to integrate to get the solution. But here it is divided by u, we cannot solve it further. We got our solution. That's it, done. Now the question is very important question that I'm discussing with you, very important, and this is a general formula that is applicable throughout the Laplace inverse. For example, remember the convolution first problem. What was the first problem of convolution? S square upon s square plus a square the whole square. This was the first problem of convolution, right? In any problem, 1 upon s can come in the multiplication. That means here 1 upon s can come. Obviously in this case it doesn't matter because ss will be cancelled. So here there is no significance. Let us consider any other example. Let's say 3s plus 4 upon s square plus 16. Let's say this is my general example. Here also 1 upon s can come. So what you needs to be done is, first of all, let us find out 3s plus 4 upon s square plus 16 Laplace inverse. And due to this 1 upon s, whatever the solution we got, we gonna integrate it from 0 to t. Is this clear? You want me to write down the solution? Let's do it quickly then. Let's say this is s plus 4 upon s square plus 16. So we need to find the Laplace of s plus 4 upon s square plus 16. I'm going to do it quickly. This will be s upon s square plus 16. And what is the Laplace? So basically, if you want to find Laplace inverse of this term, s upon s square plus 16 is cos 4t plus 4 upon s square plus 16 is sin 4t. This is the Laplace of this particular term. And suppose there is 1 upon s here, then due to this 1 upon s, it will be integrated from 0 to t and everything should be in terms of u. Cos 4u integration is sin 4u upon 4. Sin integration is minus cos 4u upon 4. That will be from 0 to t. Here, since the integration is solvable, therefore I am solving further. Here it is not solvable, therefore this is my required solution. Let us put t. So that will be sin 4t upon 4 minus cos 4t upon 4, upper limit done, minus lower limit. If we put 0, this will become sin 0 and sin 0 is 0. Minus, if you put 0 here, this will become cos 0 and cos 0 is 1. So that is 1 by 4. In short, 4 you can take it out. It's common in all the terms. Here we're getting sin 4t. Here we're getting minus cos 4t. Minus plus 1. It's done. So this is the required solution. 1 upon s can come in any problem. We are into type 3, in type 4 and so on. It can come anywhere. Because of 1 upon s, you just gonna write down a 0 to t. Suppose it is 1 upon s square, then you can double integrate. Or basically you can apply convolution also. There is no problem. See, first of all, I think we are done with this. First of all, copy. See here. Suppose it is 1 upon s square. Then two options you have. What is the first option? The first option is you solve this and due to 1 upon s square, we're going to double integrate. This is the first option. What is the next option? And suppose here also, if it is 1 upon s square, What is the option? See, we got this particular solution. Again, we're going to integrate from 0 to t. This is the one option. And what is the next option? Obviously, you can go ahead with the convolution. How come convolution? Very simple. 1 upon s square, you consider it as a phi 2s. You consider this as a phi 1s. Phi 1s, phi 2s, you can go ahead with convolution also. But simply, if it is 1 upon s square, I'll prefer to go with the double integration. Hope this is clear. That's it. Done with it. Thank you.